So the next topic which we are going to see is dynamic characteristics of measuring instruments. So in static characteristics, the parameter which we measured using the instrument, it was not changing. It was fixed, right? So that, the probability of getting errors or, facing challenges in the measurement will be minimum if the parameter is fixed. Now what about if that particular parameter is changing every instance? Like for every microsecond or a millisecond, the parameter is continuously changing with respect to time. So in that particular application, how will your instrument respond? So that is determined by the dynamic characteristics of measuring instruments. So the first parameter which we are going to see in the dynamic characteristic is speed of response. So speed of response means how fast your instrument can measure with respect to the changing parameter. Right? So how fast instrument responds to the input changes. So if it is responding very fastly, then your instrument is a reliable one. So if the parameter is changing very quickly, but the measurement can take place very slowly, then it is not obvious. Let us take for example, the flow rate inside a pipeline, it is changing within 2 seconds. So every 2 seconds you get a change of the flow rate inside the pipe, but your instrument can measure changes only for every 10 seconds. So in this case, if you are integrating the flow rate to get a final volumetric rate per hour, then the integration value will not be accurate because only 10 seconds once it is getting measuring the input changes, but actually the parameter is changing just 2 seconds. So this for this type of application, if you use that particular instrument, if you use that particular instrument, then your readings will be going to be inaccurate, right? So the next parameter is, it's almost similar to this. It is called as a rise time. So it is the time taken to reach a set percentage. Say for example, like 90% of final output value. So the example given here is the temperature sensor takes 5 seconds to reach 90% of final reading. So you have two temperature sensors. So one temperature sensor takes 5 seconds to reach 90% of the reading, whereas the other temperature sensor takes only 1 second to reach the 90% value. So which one you are going to choose? So obviously, which is having a very less time, right? You are going to choose the temperature sensor which is taking just 1 second to reach the 90% of value. So this is the dynamic characteristics of a measuring instrument. So there are a few more parameters which are related to the dynamic characteristics. So the first one is the settling time. The time taken for the measuring instrument to now settle at a particular tolerance level, say for plus or minus 2% value, right? And the other one is overshoot, right? So what is the peak value which exceeds the final steady state measurement? So the final measurement, it overshoots that final measurement and reaches another peak, so which is not desirable, right? So what that is called as a overshoot. So we see here the example given is the system overshoots the target by 5% and settle in plus or minus 2% after 8 seconds. So if you are looking for a good instrument, what will be your take on the parameters listed here? So the first parameter given here is system overshoots the target by 5%. That means the maximum steady state value, it is exceeding that, and it is again coming back to the actual true value and settling it at plus or minus 2% after 8 seconds. So first let us talk about the time. So after it is overshooting, it should return within a very less time. So instead of 8 seconds, if your instrument is able to come back within 4 seconds, then that's good, right? So you have to select the instrument which has taking less time to return to the normal values. And if say the first case, the system overshoots target by 5%. So if another instrument overshoots the target only by 1%, then it is very good, right? You can go with that particular instrument instead of this, the 5%. So consolidating all this, what is desirable? So what is what is desirable when you are considering a dynamic characteristics of instrument? So what is desirable is speed of response fidelity. So your instrument should respond to changes very quickly. So if the measuring parameter changes instantly, your measurement should also change instantly. That is called a speed of response fidelity. What is not desirable? Dynamic error lag. So if it is taking a quantum amount of time to sense that particular change, so that is undesirable. So we can say desirable is speed of response. What is undesirable? Dynamic error lag.